Hello students, in today's session of CBSE paper 2025 paper discussion on modern physics, which covers the topic dual nature of radiation matter, atoms, nuclei and semiconductor electronics of class 12 physics. In today's session we are going to discuss in detail and also with additional information. Going to very important for CBSE board exam. CBSE board exam. In earlier session, we have gone through all very basics, and basics has been cleared through illustrations, which you can review on YouTube channel Sethi Swift Learn. As the topic is going to be very important for CBSE board exams, also for all these, it is requested go through the session completely. इसी के साथ साथ मैं रिक्वेस्ट करूंगा कि अगर अभी तक आपने YouTube चैनल सेठी स्विफ्ट लर्न सब्सक्राइब नहीं किया, प्लीज सब्सक्राइब इट एंड शेयर विद colleagues and friends. Now let's start with the question and concept with additional information. Question is, atomic spectral emission lines of hydrogen atom are incident on a zinc surface. The lines which can emit photoelectrons from the surface are members of. Four options are given to, one of the option is correct. Before I start on the solution of this question, I will discuss certain things which are related to the atoms and the spectral series, which are very useful for CBSE board exams. For hydrogen-like atoms, radius of nth orbit, velocity, frequency, total energy, RCH की value 13.6. These are the dependency. RCH की value minus 36.6 आता है. Total energy equal to sum of kinetic energy plus potential energy. That is equal to total energy always negative, potential energy always negative, and kinetic energy always positive. This is the relation. And change in energy is SC by lambda, and in terms of that's 1, 2, 3, 7, 5 lambda. These are very useful for CBSE board exam, right? Also regarding emission spectrum of hydrogen atom, this is the formula. Derivative formula is wave number is given by 1 by lambda equal to RH z square 1 over NF square minus 1 over N square. This is the final decision. For series limit, we take initially from infinity. For shortest wavelength, infinity से start होगा to that one. Longest wavelength के लिए conjugative लेंगे. End of n negative difference में 1 का difference होना चाहिए, right? And these are the series. Lyman n equal to infinity to 1, 2 to 1, 3 to 1, 4 to 1, 5 to 1, and so. Similarly, Lyman, Balmer, Paschen bracket preference series. And there are the regions are also mentioned here. Ultraviolet, visible, infrared. Last series is infrared. This is visible, Lyman series, right? And this is the energy one. This is the energy one. Means if we want to this minus 3.4 minus 13.6, that comes out to 10.2 eV. This much energy is required to jump from this to this like this, right? Now in the question, it is given that zinc का work function है 4.3 eV approximately. 4.3 eV. For 4.3 eV में, this is the only n equal to 2 to 1 is the energy more than 10.2 eV is greater than 4.3 eV. So Lyman series in ultraviolet region is possible Lyman series is possible. Correct option is C. Reason being, this will, in this case, from n equal to 2 to 2, then 10.2 energy is required, which is provided. This is more, which is more than the 4.2 EV. This is more than the 4.2 EV. In this case, you can see the difference. You can see the difference. You can see and all other there is less than 4.2 EV. So this is more than 10.2. So the Balmer's Lyman series is the correct answer. Lyman series. This is equal to. Next question. Question is, the energy of an electron in a hydrogen atom in a ground state is 13.6 eV minus. Its energy in the orbit corresponding quantum number n is minus 544 eV. The value of n is. Energy का formula क्या है? This is the formula energy of. Total energy is minus 13.6 eV z square by n square. This is for hydrogen-like atom. Means other than hydrogen है, electron one है, then z हम put कर सकते हैं, atomic number उसका, उसके accordingly हम answer find it कर सकते हैं, right? Now, it is given to 13.6 eV in the ground state and minus 0.544 means apply कर दीजिए formula E equal to minus 13.6 by n square. ये तो n equal to 1 हो गया, तो if we put n equal to 5, we get this answer. We get this answer. So correct option is D is the correct option. Right? Next question. Question is, when the resistance measured between P and N ends of a PN junction, diode is high. It acts as if 4 options are given to you, 1 correct. You know diode. These are plus minus. For forward biasing, it offers very low resistance, ideally 0. And for reverse biasing में अगर इसको नेगेटिव कर दो पॉजिटिव कर दे, that is the reverse biasing. It offers infinite resistance. That is very high resistance. Behave like open circuit. Behave like open circuit. Means it allows flow of current in one direction. Flow of direction in one direction. These are the basic concepts regarding the diode of forward biasing. And when estimated the PN junction diode is high, high means it is reverse bias diode. It is reverse bias diode, which it behaves like an open circuit switch. So correct answer is D is the correct answer. Right? Next question. Question is region assertion type. We have to pick up one of the correct answer. Question is, assertion is in a semiconductor diode, the thickness of depletion is not fixed. The thickness of depletion in a semiconductor device with diode depends upon any number of factors biasing of the semiconductor. Before concluding the answer, this is a PN junction diode, this is the PN junction diode in forward biasing, and this is also in forward, this is in reverse biasing. This is the depletion region. Depletion region decreases in forward biasing and increases in reverse biasing. means that is depletion region, thickness of depletion region is not fixed. Is not fixed. In semiconductor, thickness depletion is not fixed. This is correct one. Thickness depletion in semiconductor depends on the such as factors. Yes, it depends on the factor. फॉरवर्ड बाइसिंग में ये डिक्रीज करेगा, रिवर्स बाइसिंग में इंक्रीज करेगा. लेट्स सी द करेक्ट आंसर. Both answers are true and region R is the correct answer. A is the correct option. Right? Next question. Question is, assertion is in Bohr model of atoms. Angular momentum for electron and orbital is square root of the orbital radius. According to Bohr model, electron can jump to its nearest orbit. We know angular momentum is given by mvr equal to integral multiple of h upon 2 pi. And radius of nth orbit is given by r equal to proportional. Yani Rn is proportional to n square and L is proportional to n. Therefore, L is proportional to under root R. Under root R. So this is false. This is proportional to this is true. Right? According to electron it can jump to anyone depending on the energy level. It can jump to anyone. So this is false, not nearby, not nearest to its orbit. This is the false. So we can choose the correct answer. Assertion is true and region is false. So correct answer will be, let's see the answer. Assertion is true but region is false. C is the correct answer. C is correct answer. Right? Next question. Question is, a light of wavelength 400 nanometer is incident on metal surface whose work function is this much. Calculate the speed of fastest photoelectron emitted. Concept applicable in solution. Einstein photoelectric equation. W equal to W naught plus kinetic energy maximum, and this may be equal to EV naught, or this may be equal to half m V maximum square. This is the energy of incident radiation. This is the work function. Minimum amount of energy required to emit the photoelectrons. We know the stopping potential required to stop the maximum speed electrons to apply the potential in the negative direction. Mass of electron emitted, and this is the maximum velocity of electron. According to question, work function, this is given to you. W naught is given to you. C into 10 to the power minus 19 eV, and wavelength lambda 300 nanometer, 400 nanometer. To find V maximum. V maximum is to be determined. So H mu equal to W naught plus half m V maximum square SC by lambda minus W naught equal to half m E V maximum square. We have to put the values. 6.63 into 10 to the power minus 34, 3 into 10 to the power 8 divided by divided by 400 into 10 to the power minus 9 minus EV 3 into 10 to the power minus 19 EV को कन्वर्ट करेंगे जूल में तो 1.9 10 to the power minus 19 equal to half m 9.1 into 10 to the power minus 31 into V maximum square. Solve them. V maximum comes out to be 6.63 into 10 to the power 5 meter per second. This is the calculation आप करेंगे. I have substituted the numerical values and explain the concept applicable. You know 1 EV equal to 1.6 10 to the power minus 19 joule. इसको जूल में कन्वर्ट 1.6 माइनस सो जूल में कन्वर्ट करके उसमें वो कर दीजिए आप. ठीक है. नेक्स्ट क्वेश्चन.
Before start of the next question, I would like to say that these concept clearing videos for the purpose of 11th standard, 12th standard, state boards, CBSE Board, JEE Main, JEE Advanced, NEET, CUET, and other entrance examination. These concept clearing videos are very helpful and useful, which you can review on YouTube channel Sethi Swift Learn. In addition to this, I would like to say that these papers, complete video sessions are available on Sethi Swift Learn YouTube channel, which you can review on Sethi Swift Learn. In addition to this, further, these papers, detailed solution with additional information available on website sethiswiftlearn.com. You can visit the site and have the solution. इसी के साथ साथ मैं रिक्वेस्ट करना चाहूँगा कि अगर अभी तक आपने YouTube चैनल सेठी स्विफ्ट लर्न सब्सक्राइब नहीं किया, प्लीज सब्सक्राइब इट एंड शेयर विद योर colleagues and friends. Now let's start with the question.
Question is, the threshold voltage of silicon diode is 0.7. It is operated at this point by connecting the diode in series with battery of 3 volt and the resistance of 100 ohm. Find the value of V when the current drawn is 15 milliampere. Means 15 milliampere. This is V. Current is 15 milliampere. This will be 0.7 volt. And resistance is R equal to 0. Means by applying the KVL, that will be equal to V minus 0.7 equal to 1000 into 15 10 to the minus 3. This is goes 15. V comes out to be 15.7 volt. That is the answer. Right? Next question. Question is, show that variation of binding energy per nucleon with mass number. Write the significance of binding energy curve. This is one part. B part is two nuclei with binding energy per nucleon form a nucleus with no binding energy per nucleon. What is the type of nuclear reaction? Is it? This is nuclear fusion. Nuclear fusion. Whether total mass of nuclear total mass decreases. Total mass decreases. Does the requirement produce energy? Produce very high energy. Produce very high energy. This big part is over. Right? Now show there is the binding energy per nucleon mass number. This is the graph. Binding energy per density. This is the graph like this. Right? You can go through it very well. The significance is Binding energy per nucleon is a characteristic property of elements. Binding energy per nucleon increases rapidly for nuclei with small masses and reaches maximum approximately 8.8 MV per nucleon for iron. For iron, this is the case. For iron, right? That is, nuclei with mass number greater or less than 60 are not strongly bound as those near the middle of the periodic table. The curve is slowly varying for A greater than 40, which says that the nuclear forces saturates. For greater nucleon numbers, the binding energy per nucleon decreases gradually. Later, the binding energy per nucleon decreases enough to so there is binding energy to hold the nucleons together. It is observed that nuclei with A are unstable and hence radioactive. This is regarding the significance of the binding energy curve. Right? Next question. Question is, what are the majority and minority charge carriers in extrinsic semiconductor? Extrinsic semiconductor are those when impurity is added from third group or fifth group. For N-type, majority and minority. Majority carriers are electrons and holes are minority carriers. For P-type, holes are majority carriers and electrons are minority carriers. This is the part 1. A p-n junction is formed by describe the movement of the carrier which produce current in it. This is the movement of charge carriers. Movement of charge carriers of 4 biasing. 4 bias p-n junction. You can observe it very well and define it, right? Next part is the graph shows the variation of current with p-n junction. Sorry. This is the graph. Estimate the dynamic resistance of diode when V equal to dynamic resistance equal to dynamic resistance delta V upon delta I. That is, I is 0.6. 0.6 के correspondingly I is 0 divided by 0. That is infinity. Dynamic resistance is infinite. Dynamic resistance at V equal to minus 0.6 is infinite. That is the answer. Right? Next question. Question is direction for study based questions. Read the following paragraph and answer the question that follow. Question is, when a photon of suitable frequency is incident on a metal surface, photoelectron is emitted from it. If the frequency is below threshold frequency for the surface, no photoelectron is emitted. For a photon of frequency greater than threshold frequency, kinetic energy of the emitted electron is this much. The photoelectron can be stopped by applying a potential V naught called stopping potential on the anode. Thus, the maximum kinetic energy is given by this formula. The experiment graph between stopping potential, this is the stopping potential, and this is the frequency on x-axis. The slope of line is m. This is the slope of line. We have to give the answer. The straight line graph obtained for two metals. We have to pick up one of the correct answer. You know Einstein photoelectric equation, that is W equal to W naught plus EV naught. Energy of incident radiation, work function, stopping potential, H mu equal to H mu naught plus EV naught. Reducing into y इक्वल टू एम एक्स प्लस सी फॉर्म। तो ये क्या हो जाएगा, ई वी नॉट इक्वल टू एच म्यू माइनस एच वी नॉट। वी नॉट कम्स आउट टू बी एच बाई ई म्यू प्लस माइनस एच म्यू नॉट बाई ई। तो स्लोप इज, this is the slope h by e. Slope is h by e. This is constant for everyone. H by e. This is a Planck's constant. This is electron. This is both are constant. If slope is constant, for two lines will be parallel to each other. B is the correct answer. The value of Planck's constant of this value is value of Planck's constant h by e equal to m. So h equal to ma. H equal to ma. This is the correct answer. Intercept on frequency axis and V naught on axis. Intercepts on frequency axis and V naught axis. V naught कौन सी है? Y intercept. Y intercept is H mu naught by E. H mu naught by E. And frequency of that is mu naught. A is the correct answer. A is the correct answer. Right? Now further part is, for the second part is, where the wavelength of photon is doubled. So how many times is wave number? You know wave number is 1 by lambda. It is doubled. So wave number will become half. And second is frequency. V equal to f lambda. This is constant. So f equal to v by lambda. It is doubled. So f will become f by half. So B is the correct answer. B is the correct answer. That part. Momentum of this is ignoring relative force. If wavelength of photon is lambda equal to h by p. Lambda equal to h by p. H is 6.63 10 to the minus 34 upon 5.08 10 to the minus 29. On simplification, correct answer comes out to be 13.3 pm. That is the D is the correct answer. Right? Now, I would like to request, if you are new to my YouTube channel, Sethi Swift Learn, please like and subscribe to my channel and press bell icon to receive updates on concept killing videos. Thank you.